Hi everyone, Mrs. Paglione here, week 5 of distance learning. So this week we are also going to talk about trinomials, except our trinomials here are going to have a leading coefficient that is not equal to 1. So that leading number isn't going to be an x squared, it's going to be like a 3x squared or a 5x squared or whatever it may be. But before we get there, there's a few more problems I want to do just to clarify binomials. So remember, binomials, when you have two terms, that's when you're using difference of two squares, or dots. And then I just wanted to show these dots problems because they technically have a leading coefficient that's not equal to 1. So 4 is 2 squared and 9 is 3 squared. So the pattern would be 2x plus 3, 2x minus 3. Or obviously the order can be flipped around. For here, 16 is 4 squared and 1 is 1 squared. So the pattern is 4x plus 1 and 4x minus 1. And then the last one here is 36 and 25. Well, 36 is 6 squared, 25 is 5 squared. So you've got 6x plus 5, 6x minus 5. All right, so here is the bulk of what we're talking about today. So factoring a quadratic trinomial where the leading coefficient is not equal to 1. Just as a reminder, it's ax squared plus bx plus c is our quadratic trinomial form. So what we're actually going to use is something called the British method. So the British method of factoring is basically forced factoring by grouping. Remember, factoring by grouping is when you have 4 terms, you group the first 2, group the last 2, pull out the GCFs, and go through the different steps. So what we're going to do with our 3-term polynomial, our trinomial, is we'll actually break it down so that it ends up being 4 terms. And then you can use factoring by grouping to factor it. So it's the easiest way to go through and factor these trinomials, especially knowing that we're not going to be together. There are other ways to factoring trinomials where a leading coefficient is not equal to 1. You can look those up on the internet if you want, but this is just the easiest one for me to show you because we are not going to be obviously together to go through this. So what you're going to do is you're going to multiply A and C together. Okay, so if I multiply A and C together, that's 2 times 3, which is positive 6. So I'm looking for 2 numbers that are the factors of A, C, that multiplication, whose sum is B, the middle term. Okay, so I still want them to add to the middle term, but instead of them just being multiplied to 3, you're going to multiply 2 times 3, the first and the last term. So you need 2 numbers that multiply to 6 and add to 7. Well, those 2 numbers are 6 and 1. So then what you do is you break down the middle term and you write the middle term as 6x plus 1x. Then bring down the plus 3 and bring down the 2x squared. So basically I took a 3-term trinomial, polynomial, and I ended up unsimplifying it. So do you see how if you combine these middle terms here, you're going to end up getting the simplified version? Okay, so that's basically what you're doing. You're unsimplifying. You're finding 2 numbers that multiply to the AC term and add to the B term in the middle. All right, so step 3 is you rewrite the polynomial using the 2 factors instead of the 1 linear term, and then you factor by grouping. So factoring by grouping means I'm going to take my new 4-term polynomial, group the first 2, group the second 2, pull out a GCF. So 2x is my GCF, leaves me with x plus 3. I really don't have a GCF for my second term, so it's a plus 1, leaves me with x plus 3. Then I pull out the x plus 3, the common term there, and my GCFs are what I have in my second set of binomials. So my answer is x plus 3 times 2x plus 1, those 2 binomials. And you can check it, obviously, by using the foiling method or double distributing. So looking at problem number 1. Problem number 1 is very similar to the first one that we did together. So the first thing you want to do is multiply the first and the last term. So 3 times 2 is 6. So I need two numbers that multiply to 6 and add to 7. Well, once again, that's going to be 6 and 1. So I rewrite my polynomial as 3x squared plus 6x plus 1x plus 2. So I'm basically unsimplifying it by filling in those two factors. Factor by grouping. Pull out a 3x, leaves me with x plus 2. Pull out a positive 1, leaves me with x plus 2. X plus 2, 3x plus 1. That's my answer, and I can check it by double distributing or FOILing. Looking at the next one, multiply the first and the last term together, it gives me 6. I need two numbers that multiply to 6 but add to 5. Well, that's 2 and 3. So now what I do is I break the 5x apart into positive 2x plus a positive 3x. So it's kind of like you're taking that middle term and you're unsimplifying it. Bring down the plus 3, bring down the 2x squared. Now factor by grouping. Group the first two, group the second two. Pull out a GCF of 2x, leaves me with x plus 1. Pull out a GCF of a 3, leaves me with x plus 1. So x plus 1 is my first binomial, 2x plus 3 is my second binomial. Okay, looking at the next one, see I have a leading coefficient that's not equal to 1, so I have to multiply to start to give me negative 30. So I need two numbers that multiply to negative 30 but add to negative 13. So those two numbers are going to be negative 15 and 2. So I'm going to break apart the negative 13 and make it negative 15x plus 2x, then minus 10. Bring down the 3x squared. Then I'm going to factor by grouping. So I'm going to group the first two, group the second two, pull out a GCF of a 3x, leaves me with x minus 5. Pull out a GCF of a positive 2, leaves me with x minus 5. So x minus 5, 3x plus 2 is my answer. Okay. Next one, I have that leading coefficient of a 3, so I need to multiply. So I'm going to multiply the first number times the last number, so 3 times negative 3 is negative 9. I need two numbers that multiply to negative 9 but add to 8, so that is going to be 9 and negative 1. So I'm going to break up the 8x into a 9x minus 1x, bring down the minus 3, and the 3x squared. Factor by grouping. So I'm going to pull out a 3x, leaves me with x plus 3, pull out a negative 1, x plus 3. So x plus 3 and 3x minus 1. Remember, the order of your binomials do not matter. So if you had the 3x minus 1 first, that would still be correct. All right, looking at the next one, so 2 times negative 21 is a negative 42. So I need two numbers that multiply to negative 42 and add to negative 1. Well, that's negative 7 and 6. So we've got 2x squared minus 7x plus 6x minus 21. All right, go ahead, factor by grouping. Pull out an x. Leaves me with 2x minus 7, then pull out a positive 3, leaves me with 2x minus 7. So we have 2x minus 7, and we have x plus 3. Okay, last one here. Multiply the first and the last, it gives me negative 24. Two numbers that multiply to negative 24 and add to negative 5. So that's going to give me negative 8 and 3. So this is 2x squared minus 8x plus 3x minus 12. Now you might be asking yourself as you're going through this, well, do I have to put it in that order? No, you don't have to put the negative 8 first. And I guess I probably should have told you about this a little bit earlier. But what if I switch the order? What if I put the positive 3x and then the minus 8x minus 12? you'll see after I factor them both, and I'll factor them parallel so you can see it, that you're going to get the right answer. It's just the parentheses that you're going to have in common are going to be different. So if I look at the first one and I put my parentheses there, I'm going to factor out a 2x, leaves me with x minus 4. Factor out a positive 3, leaves me with x minus 4. Come over here to this example. Okay, factor out an x, leaves me with 2x plus 3. Factor out a negative 4, and it leaves me with a 2x plus 3. Okay, continue factoring by pulling out my common set of parentheses, my common binomial. That gives me 2x minus 4 and 2x plus 3. Okay, so that's my answer there. For this one, my common binomial is 2x plus 3, but then I'm left with an x minus 4. So it really doesn't matter the order at all that you put the factors in when you create your 4-term polynomial and you start factoring by grouping. It just means that your parentheses are going to be a little bit different, but you should still get the right answer. And once again, you can give me either answer. All right, well, you can go ahead and jump to the homework, or I can see you soon in the live meeting. I'll talk to you guys soon.